All right, so my talk is Idealism, Digital Physics, and Christian Neoplatonism. And first I would start with a verse here. How do I scroll on this?
Just move it around and it should appear.
What?
Oh, you know what?
Cursor's not real.
There is no cursor. I haven't used a Mac on this before.
This is the usual, and
We want a different. Oh, here.
let's see. Does that show? Yes, it does. So once you point on
There we go. I
if
see
you
it.
move it aside, then you're okay,
Yep.
and we can go back.
Okay,
Yeah.
so my talk is Idealism, Digital Physics, and Christian Neoplatonism. And I first thought I'd start out with a verse here. It's Romans 1:20-22. It says, "For since the creation of the world, his invisible attributes, his eternal power and divine nature have been clearly seen, being understood through what has been made, so that they are without excuse. For even though they knew God, they did not honor him as God or give thanks, but became futile in their speculations, and their foolish heart was darkened. Professing to be wise, they became fools." So now, from a science perspective, just growing up, like taking science at university, this kind of seems odd at first glance to the average academic. I mean, how is God clearly seen from what is made? Can't we just explain the world in purely material terms, right? I mean, you have plenty of professors today that seem to make very compelling arguments that's the case, and so start to wonder, what exactly is Romans 1 talking about? And so why do we need the unseen to explain the seen when we have a pretty good material explanation for everything as it is? Well, it turns out that isn't quite the case. The one big clue we have is the problem of consciousness. And this is, materialist accounts cannot explain consciousness due to the subject-object gap. There's an inner subjective experience, but there's also an outer physical reality, and you can't find an emotion on a piece of wood or something. So material explanations require, and furthermore, material explanations require empirical accounts, which require conscious sensations of things. So, for example, there's orange light coming out of my drive here, and well, that's a phenomenon. That's a subjective sensation, but we're using that to define matter, which is kind of peculiar. There's something purely subjective that seems to be almost out there in a sense. So thus in order to understand, we need to understand consciousness before we can truly know anything about the outside world. And so because of that, we need to develop a metaphysics of consciousness before we can even really know in a robust sense. I mean, we can know in a practical sense what's out there, but in a robust sense, we can't have any true knowledge of things until we explain consciousness, because that's how we explain perceptions with. So we have a bunch of questions. Is the mind a process, property, or substance? Is it emergent or non-emergent, material or immaterial, and are there one or two substances? And then where exactly is consciousness? So to start out with, we have the Searle's Chinese room thought experiment. This is to test if it's a process or not a process. And so the idea is there's a man in a room who's manipulating Chinese symbols. He's getting little notes from outside that have Chinese sentences written on them, questions written on them. And he then looks in his books to see, what the symbol, what codes correspond to those symbols. He looks those codes up in another book and is thereby able to generate responses in Chinese that he then writes down on a piece of paper and sends out. But the catch is he doesn't actually understand Chinese itself. He's just manipulating stuff from rule books. Right? He takes the input, processes through a bunch of rule books, and spits out output without knowing a single word of Chinese. And so this is a process, and commonly neuroscientists will say that the mind is a process. But the problem is that if you do that, well, he's doing a process exactly like someone who would understand Chinese would. The problem is he has no understanding of Chinese. It's the difference in the syntax of the books versus the actual semantic understanding that someone who knows Chinese would know. And so therefore, consciousness cannot be a process, because if it was a process, you'd be able to understand semantics out of it, but you can't. And then next is the mind of property. Well, the problem with this is here we have a mental property attached to a physical substance. And, well, if that's the case, then you're not really causing anything. You're just kind of piggyback on this material substance, and the material substance is moving along, and you have no control over it. It's just, you're kind of like hijacked, as it were, by the matter underneath. And so because we can obviously do things, we have control over actions, Even if there's no free will, we are the causes behind our actions. There's mental causation there, and therefore the mind cannot be a property either. And if it's not a property or a process, it has to be a substance. Now, next question: is consciousness emergent? Well, there's the problem of qualia, and qualia are what it is likeness of a given sensation. For example, there's this blue-green font I'm using here, and that would be an example of a qualia. And maybe you could reduce that to blue and green, and maybe the green down to blue and yellow again. The trouble with this is, though, is you can't reduce blue or yellow. They're completely irreducible. And if something's irreducible, that means that it can't be emergent either, because if it was emergent, you could reduce it to what it's emergent from. And besides, emergence only adds syntax, and objects are syntactically arranged to produce larger objects. You can't, for example, you see you have building plans for a house. You have bricks and mortar and wood and so on. You put those together, and it produces the building. The problem is there's no new meaning added to the building that's not already in the syntax of the building plans. There's no semantics added. So therefore, we have to conclude that consciousness is non-emergent and therefore fundamental. It's a fundamental substance. Then we have the question, is the mind material or immaterial? And for this, there's a whole raft of them, but I just picked a handful of these because this could go on forever if I gave you every single thought experiment on this topic. First one is Mary the color scientist, also known as Frank Jackson's knowledge argument. And the idea is there's a scientist who has been locked into a black and white room since birth. She's never seen the color red, but she happens to be the world's foremost expert on color vision. And she knows everything about the wavelength that corresponds to red, the cones and rods in the back of your eye, the neural signals that go to the occipital lobe. She learns every physical detail there is to know about the color red, purely materialistic understanding, but she's never seen red in her life. So this is kind of a weird thing. She knows everything material about red, yet she does not know red. And one day, she leaves the room and she learns something new, and that is the experience of what seeing red is like. And so, well, if she knows something new, if she had the complete set of material knowledge beforehand, and yet she learned something new afterwards, that has to be non-material knowledge by definition, because beforehand she had the complete set of all material knowledge. And so therefore, the knowledge of the sensation of red is something that is immaterial, and therefore the mind has to be immaterial. Next example is Plantinga's evolutionary argument against naturalism, and this was actually a forerunner to this was from C.S. Lewis in Miracles. He says, all possible knowledge depends on the validity of reasoning. If the feeling of certainty which we express by words, like must, be, and therefore, and since, is a real perception of how things outside our own minds really must be, well and good. But if this certainty is merely a feeling in our own minds and not a genuine insight into realities beyond them, if it merely represents the way our minds happen to work, then we have no knowledge unless human reasoning is valid and no science can be true. So the problem here is, well, actually, Darwin actually explained the problem. This is kind of funny because he kind of invented Plantinga's argument on his own a century before Plantinga. He says here, but then with me, the horrid doubt always arises whether the convictions of man's mind, which has been developed from the mind of the lower animals, are of any value or at all trustworthy. So basically, if our minds are just the result of purely accidental chemical and material processes, then we have this serious problem, because that means our rationality and our knowledge and our understanding of truth are also the result of purely material processes. And so, well, that's the problem, because then we have mindless material forces producing mind, but if mindlessness is behind rationality, can we really call rationality rational anymore? It's just as mindless as the irrational matter behind it. So the lesson here is mindless material brain processes cannot be trusted to produce such things as rationality and knowledge and so on. And then, of course, there's Chalmers' p-zombies, and this was kind of a simple thought experiment where he's pointed out that you can conceive of a material body. He calls this a p-zombie or philosophic body that walks like a talking conscious person, talks like a conscious person, acts like a conscious person, but maybe it's just a really sophisticated automaton and there's no actual consciousness inside of it. And so, since this is conceivable, that you could conceive of a body without consciousness that just acts conscious, then it follows that whatever consciousness is, it's something in addition to a material body, and therefore consciousness cannot be material. And of course, we have Little joke here. Daniel Dennett's response is, the reason we can't get inside someone's head is because we just haven't studied the brain enough more. He's not realizing, of course, that that's strictly a third-person way of looking at the world, and you can't get, the entire point of Chalmers' argument was that you can't get first person from third person. And last one is probably one of the earliest ones, and it's actually one of the most intuitive ones, which is why I like it so much, is Cartesian skepticism, and that is we can doubt the material world, and if our minds were material, we could not doubt them, or we could doubt them either, because we can doubt matter, but we can't doubt our own minds. Right? There's the whole "I think, therefore I am" from Descartes' Meditations, and so therefore our minds cannot be material. So we thus far have mind as an irreducible, mental substance, non-material substance. And then the question is, well, how many substances are there? Is there, one substance, or is there two substances, like a kind of a ghost in the machine, like Descartes would argue? Well, the problem with this is what's called the interaction problem. So, for example, say I'm moving my material hand, or so we might call it material, but the problem is now, in order to move a material object, you have to put a material force on it, which means that there has to be my mind has to ultimately at some point be, exerting material force on my neural pathways, which then run down to my hand, or my muscles, and then my hand. And so now my immaterial mind, I just demonstrated was immaterial before, is now producing this material force, and that seems kind of paradoxical because it doesn't make any sense to say that, right? So, because it would make it material again, it would have material properties. So immaterial things cannot produce material forces because if they did, well, then they would have material properties and therefore they would be material, and so therefore substance dualism is necessarily incoherent. And now we have my first argument for the existence of God. It's very simple. Mind is fundamental, as a fundamental immaterial substance. Substance dualism is false. Therefore, it follows that matter can't possibly exist, at least not in a fundamental sense, in all is mind. And so therefore, we're inside of Bishop Berkeley's giant lucid dream. This is kind of a very infuriating argument because it cuts off any possibility of material explanation to the mind. You have to question back against the argument to defeat it. So I kind of added that little slide in. Atheists like to argue against dualism, so I figure if, that's one of their tools, and I've just turned their tool on them, and they have no defense on it because they'll have to question back to defeat the conclusion. And then the next question, when we add to our metaphysics, is where is the mind? So we have access to these, Platonic objects like the number 2, or, maybe an emotion. I don't know if they call it a Platonic object, but you have concepts that you can't find anywhere in space or time. You can't, point out somewhere and say, here's this logical proposition floating somewhere in space. It doesn't make any sense to say that ideas are out there in the physical world. So they're kind of outside space and time. But then on the flip side, we have this situation where you see immaterial qualia right here in the physical world. There's the color sensations on the screen behind me. And so we have this interesting thing where the mind has access to outside of space-time, but it also has access to inside of space-time. So now, what picture does this paint? Now, this is idealistic Neoplatonism, and the Neoplatonists had this idea that there is the Platonic world outside and there's the material world inside, but unlike classical Platonism, they had this idea that what we call the material world is not really material, it's kind of a projection from the Platonic world. And they call the Platonic world the pleroma, which is this non-physical Platonic realm, and then the hule, it's spelled Heil, but it's pronounced hule. And that's the physical world, and the human mind here is kind of in between. It has access to outside, but it also it's kind of stuck in the physical. And so physical reality is a mental construct generated from a Platonic world, which is completely immaterial. So that's our picture from philosophy of mind that we've generated, all purely a priori. But now, even though that's philosophical, you can kind of turn that into a scientific thesis, and that's the second part. Digital physics. And the question is, can you test idealism, or is it merely a philosophic hypothesis? Well, you might think this is something you could never answer, but the catch is that the two models of the world have different predictions that are very subtle when you get into it. Material world would generate just clockwork behavior from atoms in the void, Whereas by contrast, an idealist universe describes the world as based on information processing. And computer scientist Brian Whitworth compared these two to the physics of our world. And the first example, I don't know why it should have been spread across. Meet the physics student Sheldon. And Sheldon's a physics student. He's never heard of relativity or quantum mechanics before in his life, however, but he decides to go into school to learn these things. However, before going here, he gets stuck in a car accident, and he ends up in a lucid dream and a coma for the next 10 years. And of course, I know Sheldon doesn't drive if you watch Big Bang Theory, but I just had to put him in there anyway. So one day in his dream, he doesn't realize he's dreaming, but one day in his dream, he boards a supersonic plane, and the problem is it's going 750 miles an hour, and the thing is that he doesn't realize he's still in his dream, and I may be wrong on this number, but I believe that the human mind can only process speeds up to 1,000 miles per hour. You can't see, you move too fast, you won't see it. The problem now is that his world is actually generated from his mind, but he doesn't realize it. Everything inside that lucid dream is being generated by the information processing in his brain, and therefore nothing in his world can go faster than 1,000 miles an hour. So now let's suppose that one day he's on the supersonic jet going 750 miles an hour north. Another supersonic jet moves 750 miles an hour south, and he has a speedometer a speed detector to try and measure just how fast the plane is going. And it should be going 1,500 miles an hour with respect to him because, 750 plus 750. The problem is only speeds up to 1,000 miles an hour can work in this world. So he has this very peculiar situation where no matter how fast he goes into it, it only goes up to 1,000 miles an hour. And he's very confused by this. And furthermore, the closer he gets to 1,000 miles an hour, the more his brain slows down in processing the other plane. And from his perspective, it looks like the person on the other plane is going slower. And so from this, he reaches two premises about the world. One is just tautologist, and that is the laws of physics are the same in all reference frames. That's Galilean relativity that we all learned in basic high school physics. The second is that there is a maximum velocity that is the same in all reference frames. Now, does anyone here know what you can derive from just those two premises?
Einsteinian relativity.
Exactly. All the mathematics of special relativity derives from those two premises. The catch is he's never heard of special relativity before in his life, and now he has a situation where he wakes up. He's developed all this math in his dream. He wakes up, goes to school, and lo and behold, he suddenly has relativity. And he discovers, where did this come from? This is what I derived from my dream from what I was studying, and how do you guys know about it? Except, of course, it's, the speed of light rather than 1,000 miles per hour. That's the only real difference. Now, if you think that's spooky, it gets worse. So what happens when you guys open too many pages on your computer? Slows down, right? So let's kind of put that into, that's an information processing effect. But let's say we put that into a video game like RuneScape here. And, it's loaded up in different grids. And so you put too many objects in one grid. Well, the information processing allotted to that grid is starting to be used up more. And because of that, the computer, or the processing for at least that area begins to slow down. And so you have a situation where there is one grid with a whole lot of stuff, another grid with not much stuff, and the grid with the whole lot of stuff seems to be running slower. Everyone's moving through it, kind of moving in slow motion through this other grid that has all the stuff in it. Well, that's what sounds like general relativity, doesn't it? You have too much mass in an area, and time begins to slow down, and space bends, and so on. Now, if you think this is just a coincidence, in 1995, a guy named Ted Jacobson actually demonstrated that something like this is actually true. This is discovered that what's called the holographic principle, which basically just says that the information content of an area is, the size of an area is proportional to its information content, or entropy. And when you combine the holographic principle with entropy, you can actually derive general relativity from scratch. And if you put more information in a region of space than is allowed by basically the holographic principle says it's S equals A over 4 is the relation between area and entropy. And entropy is S and area is A, obviously. So now see you have a given region of space, and you want to put more entropy in it than is allowed by the bound. Well, now you have a situation where you have to put a larger space into a smaller space, and the only way you can do that is if you bend the space in. And so you have this, you can then see how relativity derives out of that. What's fascinating is you actually can, when you take this to this extreme limit, you actually have this situation where space curvature is dependent on information processing, and time dilation is dependent on information processing, which is, it's not just a coincidence. This actually is the best explanation in quantum gravity now for why space bends in the presence of large objects. So now we have, I'm going to try and get out of this for just a moment because I want to show you guys a video. That's the relativity half of this, but then there's, where's the,
You want to get that?
yeah, I'm going to get that video up.
You can see more here.
Yeah, the video is really fascinating.
Let's go. Put that down, and then do you have?
Well, it's down here. You actually start to see certain types of effects in, you see in quantum mechanics that you actually see, that you also see in computer games completely by accident. And this is a guy from Second Life.
Unfortunately, we can't show that, so
yeah,
we're going to have to.
You kind of, I copied a snapshot of the screen of it anyway for the tunneling activity, but you can actually see certain types of quantum effects in Minecraft. Now, I was also going to play a clip from Second Life, a conference given by the founder of Second Life, where he had a situation where you have a marble in a cup, and you put the marble in the cup one night, and you come back the next day, and the marble's outside the cup. And it was weird because he discovered this was an information load processing effect, and the marble would always appear on the other side of the cup simply because the computer couldn't process both the marble and the cup at the same time always, and so you have the situation where sometimes the object would pass through the cup wall. And well, you see that actually in quantum mechanics. We just call it quantum tunneling. And oddly, the larger the object, the better chance it has of tunneling, or the larger the energy of the object, the better chance it has of tunneling through the wall, which is a larger load being processed. So he had basically had quantum tunneling in mind in Second Life, but I had this little clip here in Minecraft where you had cows and chickens passing through a fence as well.
So tunneling, of course, is this phenomena where if you have a marble and you have it in a cup and you shake the cup just a little bit, just enough to roll the marble around in the bottom, if it's a big classical marble, you can shake that cup forever. And when you come back, you'll still find the marble in it. You can do it as long as you like. You can do it for 1 billion years. It doesn't matter. But as you guys probably know, in the quantum mechanical domain, you get this very odd behavior, which is if you shake the cup just a little, and then you come back the next day, marble's gone. It actually just left the cup. It just went through the sidewall of the cup. It tunneled, as we say in quantum mechanics, through what's called a classical barrier. It just left. There's a statistical probability that a very small quantum mechanical particle, like an electron, will just leave the container that it's in by way of the wall. And there was this thing that was going on at the time. I was basically starting to do some of the early thinking in engineering around physics simulation in Second Life. And I was encountering this problem, which was that when you try to basically simulate little marbles running into each other in a physics simulator on a computer, that is to say, when you try to redo the laws of physics on a computer, and the computer has only a finite amount of power, you run into this very interesting problem, which is that, well, and I'll say what the problem is, and then I'll go back to why, but basically, if you leave a marble in a cup in Second Life, and you leave all night, and you come back, what happens? The marble's gone. And it actually turns out that that problem isn't fixable. So what I'm trying to say is, if your computers are only so fast at simulating a virtual world, that is to say, if you have a finite number of computers, and you want to simulate a certain amount of virtual space, you run into this problem, and it turns out you can't solve it, that if you don't want things to bounce out of, if you don't want that little marble to leave the cup that it's in, you actually would have to have an infinite amount of computing power to guarantee that it won't over a certain amount of time. Does everybody sort of see where I'm going with this? So what was just incredibly interesting to me, and I was already very interested in virtual worlds, was this bizarre fact that the computational limits imposed by simulation when you were simulating a virtual world on a computer essentially resulted in the same kind of, I'm just going to say, artifacts or problems that make quantum mechanics weird.
Of course, there's pixelation. That's just the fact that at the smallest possible scale, we find that space-time is pixelated. There's Planck length and Planck time, and there's discrete units of quanta and everything, just like you'd see in a computer game. And so in the last one, I had this cool clip lined up. Unfortunately, we can't play it, of Cooper pairing and superconductivity in Minecraft 2, where they had these two minecarts that were linked together. You put them together, they just automatically link, and they start going around with no resistance. And that very closely resembled Cooper pairs in superconductivity, where you put them together and then they begin to speed up with no resistance. All right. Now, the second part, I'm guessing a lot of people probably know what this is, but I'll quickly go and run through it anyway. The wave-particle duality. Firstly, you guys are pretty familiar with the double-slit experiment. You have the screen, and you have another, or rather the emitter, and you have the first screen with two slits in it, and there's a screen behind that picks up the interference pattern from those two slits. Now, if you fire through, particles, you'd expect to see two bands from the two sets of BB gun shots that are being fired out there. You just have these two bands in the back. If you have waves, you end up with this interference pattern, which every point where the waves interfere, you have these crests, maximum and minima, on the back wall. Now, with quantum particles, it gets a little interesting because, well, we have this situation where you shoot through one marble, or one electron, as it were, and it ends up, hitting one exact spot and not another spot. There's no interference pattern. But if you keep doing this for, an hour or so, you get this peculiar pattern, like seen here on the left, where these little marble strikes suddenly begin to resemble an interference pattern. So the problem with this is, though, is that the electron couldn't have interfered with anything because it was going through by itself. There's nothing there to have it interfere with. And so the conclusion with this was they realized that you have this wave-particle duality where when matter isn't being looked at or measured, it behaves like a wave, and it's spread out in this probability distribution, a wave function, or described by a wave function anyway. When you look at it again, you end up with your particle distribution again. Well, this became very troubling back in the 1920s. Einstein didn't like this at all because it kind of caused some serious problems for reality being real in the sense that we would think of the word real. And so he posed this paradox with two of his colleagues, Podolsky and Rosen, which is called the EPR paradox. And he basically said you have two particles sharing the same wave function, and the problem now is if you separate these particles, you measure one, the other one should collapse instantly too and change on their property instantly, even though it's miles away, and this violates locality, and that's completely insane if the world's physical, and so therefore quantum mechanics can't be true, he said. Well, they did the test, and with the Bell's inequalities, she tested this and discovered that, lo and behold, this phenomenon that Einstein thought was impossible actually does exist, and that's what we call quantum entanglement. You have two particles that have a superposition of, say, one state and another state. You measure one particle, and then instantaneously, a million miles away, the other particle flips to the opposite state. And, well, some people, they really, really wanted to keep their realism, and so they posited non-local hidden variables. Well, I'm not exactly certain on the details of this experiment, but I do know that in 2007, they actually had this called the Leggett inequalities, and then Anton Zeilinger from Vienna tested these, and he discovered that, well, these fail also, and so therefore, not only is local realism false, but non-local realism is false, and therefore, realism on the whole is false. And so this caused some serious trouble when this came out in Nature. And a really vivid example, a really vivid demonstration of quantum non-realism comes from the Koch-and-Specker theorem test. And does anyone know about the three cups in a ball trick you see at circuses? You always try and pick which cup it's under, and you always get the wrong one. Well, what they did is they had this experimental setup where they had the particle could be in 3 different states, possibly, potentially, and you'd always have to set the context of the experiment up so that you could measure one property or another property. And the problem was that each time you did this, no matter which property you selected for, you always got it wrong every single time. And so we now have this kind of peculiar situation where, if the world's real, the particle should have one property. You expect it to be right at least a third of the time, right? I mean, it's got to be something. But no matter what you do, you always get it wrong. And so therefore, the particle could not have had properties prior to measurement. And so Zeilinger concluded from this, there is no sense in assuming that what we do not measure about the system has reality. And so this is one of the coolest examples of non-realism. And then just to make sure, some people have criticized this about my model. They say that this is different from philosophic realism, and well, I quickly just point out the definition of philosophic realism and compare it to the scientific definition. And philosophic realism says physical reality exists independent of observation. Counterfactual definiteness, which is the term used for scientific not scientific realism, but realism in the objective reality sense. The state of a system exists independent of a quantum system exists independent of observation. So you can see they're really the same thing. Realism has been officially falsified as of 2007. Lastly, I know it's insane, isn't it? I put this up to atheists and they go stark raving mad. Then there's macro-realism. Some people say that, well, this just applies to the quantum regime. It doesn't scale up to the macroscopic regime. And, well, that is true in one sense. You're not going to see cars tunneling through garage doors, or if you do, you're going to have to buy a new garage door. But they tested this also. They had an inequality to test this also. I mean, the quantum effects are still there at the macroscopic scale, just very, very tiny. They don't, they're not visible, but that doesn't mean they're not there. So they had tested these. This is the Leggett-Garg inequalities, and these were falsified by 2 of Zeilinger's students in 2011, Hoffler and Bruckner. And the conclusion of this is that there are macroscopic quantum superpositions, and what we call the classical world is just a limiting case of the quantum world. And then they had some loopholes in those too. The only way this can be false is if the Hubbard-Bell-Leggett-Garg inequality is not violated. But the problem with that is right in the paper they say, in order for that to be violated, a realistic explanation of an observed violation requires either the failure of the Bell locality, which means that entanglement is false, but we just already knew that entanglement is true, or a preparation conspiracy of finely tuned and non-locally correlated noise. Well, basically, the last part means that if materialism really is true, if realism really is true, then it's because the flying spaghetti monster planted all the quantum states in the universe to test the atheist faith in materialism. So they're kind of at their last straws right now. It's kind of funny to watch it. So this is an example of macro realism and why the objection that it doesn't apply to the quantum scale, the macro scale doesn't work. You have Neo in the matrix, and you have there's these tiny matrix code effects that you zoom down, you see those little quantum tunneling effects you would see in the video games at a very tiny scale on his hands and so on. He doesn't see it because he's at a much higher level of resolution, but none of it's real anyway. He's still in the matrix even though he can't see he's in the matrix because all the weird matrix effects are very, very tiny to him. Now that's what information processing physics does to matter, but when we get to space, things get really spooky. Actually, you're discovering that not only does matter doesn't exist in the way we think, but space doesn't really exist either. The first clue with this is the holographic principle. That's kind of what I got to a little bit before, but I'm going to run down a little explanation of it now. So the question is, how much information can you extract from a region of space? well, you ask questions about objects and so on, and at some point you have to get down to this very tiny scale where in order to ask questions or make observations, you have to push it to this limit where you run into the Heisenberg uncertainty principle, and you push past that, you measure the position value very well, but the energy value is now messed up. It starts getting really big. And you keep pushing it, and well, the energy value at one point, that goes over too, and it's so dense now that it creates a black hole, and you can't ask any more questions from the other side of the black hole. Can't make any more measures because nothing comes out on the other side of a black hole. So there's a limit to how much information you can extract from a region before the region turns into a black hole. Well, there's another guy named Bekenstein, Jacob Bekenstein, who had a different problem, and he was asking, well, say you dump entropy into a black hole, and it seems you can destroy entropy and therefore violate the second law of thermodynamics, and well, that just seems weird. And so he didn't like this, and he proposed this solution. This is now kind of consensus in physics, where the entropy, which is the measure of information content, is defined by the surface area of the black hole. And that's the maximum amount of entropy you can have in a region of space before it turns into a black hole. Or it happens to be the same bound as before. So the amount of entropy you throw into a black hole happens to be correlate to its surface, which also happens to be the exact amount that defines an area before it turns into a black hole. And so there's this correspondence now between what seems to be on the interior of a black hole, a three-dimensional ball, you'd think of it, and the surface area. It's not really, the surface area isn't, the volume, really isn't there. It's the surface area that's defining the volume. And so that's the ADS-CFT correspondence, which is holographic duality between a two-dimensional sheet or a two-dimensional surface and a three-dimensional volume that encloses it. And then they discovered later that this applies to the universe as well, and so the conclusion is that what we call space-time is actually a hologram. And of course, there's the Big Bang, which people have disagreements about that sometimes, but the point is that even on completely secular science, it means that physical space-time had an absolute beginning at some point in the past, and therefore it can't be fundamental. This last one is kind of cool. This is quantum entanglement and non-realism when you put them together. Space is defined by distance between locations. That's just kind of tautology. You can't talk about space unless there's 2 points to measure that space from. And before collapse, however, remember I pointed out that particles don't have properties before collapse? Well, some of those properties are locations. And because some of those properties are locations, you have this situation now where, well, the locations don't exist prior to collapse. The problem is, so there's no space before collapse. But now the catch is that this isn't just between two entangled particles. Well, it is between two entangled particles, but the problem is that the definition of entanglement is when two or more particles share the same wave function, and well, there happens to be a wave function for the whole universe, and so therefore it follows that everything is entangled, and therefore it follows that no locations exist before collapse, and so therefore space is just an illusion of observation. There's nothing there before you look at it. Now that sounds pretty radical and almost crazy. However, curiously enough, a whole bunch of high-level quantum gravity theorists are just that crazy, beginning with Albert Einstein himself. He didn't understand, they didn't have enough knowledge to really work on quantum gravity back then, but Einstein knew kind of where the solution lay. And this was on a letter he gave to David Bohm on the matter. He said, we have to find a possibility to get rid of the continuum together with space and time altogether. But I have not the slightest idea what kind of elementary concepts could be used in such a theory. So basically Einstein is admitting that in order to explain quantum gravity, you have to treat space-time as an illusion. This is Fotini Markopoulou from the Perimeter Institute. Space-time is not fundamental. Space-time is, if you like, a kind of emergent effect from something else that underlies it, and that something else could be information the following way. That was from a talk she gave at a World Science Festival. She's one of the, and the next quote is, my guess is just space doesn't exist. And then the next one is Lee Smolin. This guy's actually an atheist, which is kind of interesting considering his conclusions. He says, when we imagine we are seeing an infinite three-dimensional space, we are falling for the fallacy in which we substitute what we see for an intellectual construct. And Markopoulou and Smolin happen to be two of the world's leading loop quantum gravity theorists. So these guys are like the very cutting edge of their field. And Smolin goes on, the analogy between the history of the universe and the flow of information in a computer is the most rational scientific analogy I could make. And then there's Hermann Berlin, who's a string theorist from Princeton. He's very famous. He and his brother are two of the world's leading string theorists, and they're very into entropic gravity, which is a field of quantum gravity. He says, information is going to be our starting point, and space-time is not something that we start with. We forget about what space is and time is, and by thinking about what the information is doing, then space-time will be emergent. It will just come out of a bunch of zeros and ones. So that's pretty indicative right there. Now, by the way, that Whitworth guy I mentioned at the beginning, he mentioned that he had his whole, you see all these virtual reality properties? He had a whole list of these, and he discovered that all of the weirdnesses, not just the ones I showed you, but all the weirdnesses you see in modern physics combined all resemble virtual reality effects. And well, if space is an illusion generated from information, that kind of leads to the conclusion, the unsettling conclusion, our world is a virtual reality. Now, the next part of this is a little bit uncomfortable to physicists. They don't like bringing consciousness into physics, but we're going to do that anyway. So, there's consciousness causes collapse. Remember before when I said that you look at the wave function and it collapses, and well, they'll say that it's not your mind that's doing the looking, it's a measuring apparatus, a camera or a photodetector or something. But the problem with that is well, that's also a quantum object. We just demonstrated before that macrorealism entails that, or the falsity of macrorealism entails that, large things need to be collapsed too, and they've actually seen large things being collapsed now. You can actually see with the naked eye. So we have this problem where, so the camera detects the object, but now who collapses the camera, and so on. And there's this famous Wigner's friend thought experiment where there's a cat stuck in a room, and the cat is, a cat in the box rather. It's a Schrodinger's cat. It's either dead or alive before you look at it. But then you open the cat up and open the box up, and it collapses, being either dead or alive. And Wigner wants to do this experiment, but he decides to go to lunch and gives his friend over to do the experiment instead. And he locks the door, and then he comes back from lunch, and before he unlocks the door, well, he's not looking at his friend or the cat. His cat and the friend are in superposition together. There's a happy friend and a live cat, or a sad friend and a dead cat, and then he opens it up and looks. And so the problem is that collapse is always relative to the reference frame of the observer, and so therefore it has to terminate on collapse at some point, on the consciousness at some point. So that's the difference between Copenhagen just kind of leaves that unended, and von Neumann kind of completes Copenhagen. Now, a lot of physicists don't like this very much, and they had a poll a couple years back that Zollinger did on physicists asking the question, does the observer play a role in quantum mechanics? And the results in this were kind of interesting. Some 50% of them, 50+% of them said that it plays a, quote, distinguished role, a role in the formalism, but no distinguished physical role. And the next question was, does it, and it was, the next option was, yes, it plays a role in the physical world. And that was only 6%. And this is kind of funny because what it demonstrates is that what the physicists are saying that picked the first option was that they know the math says, they say that the formalism says that consciousness does cause collapse, but they're saying that they don't believe their own math anyway. And I actually pressed a couple of physicists on this, and it turned out they didn't really have any good arguments, and they just got frustrated. It was pretty. One of them actually, well, one of the excuses is that we don't know enough about quantum mechanics yet to really say, and so they're just saying this is kind of an instrumentalist view, and they're not treating it as real, just as a way to describe things until they get a better theory. The problem with that is well, we had all those tests beforehand that ruled out all the loopholes, so that doesn't really work as an excuse anymore. And then, of course, there is the, which leads to the ultimate conclusion, is the anti-anthropocentric bias. And I actually pressed one guy on this, and he said, we don't know, but it's certainly not consciousness, because it was consciousness that would make humans special in the universe, and that's ridiculous, and so on. I didn't say it was a human mind doing all the collapsing. But he didn't want that because he's an atheist, and so he couldn't have that conclusion, even though it's like, we don't know what it is, but it's certainly not that, even though all the evidence points to that. Now, that's the first way to bring consciousness into physics, but that's really controversial, obviously, even though it shouldn't be, because it's pretty obvious what they're doing there. The second way is kind of clever. This is integrated information theory. This actually comes from a guy from my state, from Madison, not Milwaukee, named Giulio Tononi, and you notice that materialists have this integrated information theory. You notice that there's this problem with understanding consciousness, and even materialists are going to disagree on what consciousness actually is, right? Some people will say it doesn't really exist at all, or it's emergent, or it's a brain process, but they don't know which part of the brain. And so what he said is, let's forget who's right about that, and maybe we'll even throw dualists and idealists in there, and we're not even going to ask the question, what is consciousness in terms of something else? We're just going to ask, what is consciousness like from a first-person perspective, and quantify that, and we're going to deal with how to tie it into the outside world later. And so, well, if you look at your own consciousness for a moment, all you have are your thoughts and your ideas inside your mind, and your perceptions outside your mind. And all those things are just information. And they're integrated together into a single state. And so he decided to take this on board, and he calls it, that's his integrated information theory. There's phi integration, he calls it phi. So conscious states are simply integrated information. Well, as it turns out, when you apply this to quantum mechanics, entanglement produces phi integration. So when you have an entangled system, you have a small amount of integrated information there. Now, Tononi actually doesn't really have a problem with this because he's a panpsychist. He thinks it's a material substrate, but he thinks that, there's information there. And he thinks it's kind of a weird effect of his model where you have little states out there that have bits of consciousness, but he doesn't think it's a problem because it's not consciousness in the highly developed way that we have it. So he's like, whatever. But this has deeper implications when we go back to the physics I just mentioned before. Now, the cool thing is this integrated information theory is actually probably the foremost theory in cognitive science right now. Like, everyone's jumping on board this, which is it's kind of interesting to see where this is going to go. Now, the last way to tie physics into consciousness is quantum cognition. And this was from just last year. They discovered that certain cognitive processes can be modeled by the Schrödinger equation as a wave function. So, when you sometimes kind of vacillate between two choices or two opinions, and you're kind of holding both at the same time. They seem conflicting, but like you can't really make up your mind, so you sometimes maybe even double think, and you think two things at the same time that can't both be true, but you kind of think them anyway. Well, that was one of the examples they used. They had I saw an article on this a while back, and I don't remember all of the details, but I do remember that that was one of the best examples. And anyway, well, that's superposition in the wave function. Remember before when the particles in that superposition of locations, kind of a probability smear, they discovered that those holding conflicting opinions and so on resembles the behavior of the Schrödinger equation. And when you actually do research on asking people opinions they have about things and so on, and map it out in kind of a scientific, take hundreds of people and map it out in a scientific fashion, they discovered that these thinking processes resemble the Schrödinger equation. And they modeled this further, and they found that you can actually model a lot of other brain processes very efficiently as well. And so now we have this situation where you can model thoughts as something that happens before collapse. But they didn't say that it actually was this way. They said that it modeled this way, but it's actually classical. But, well, we'll see where that goes. I have a sneaking suspicion that it really is quantum and not just behaves quantum. So now we go back to the holographic correspondence. I'll show you how this ties in. Space-time is, space-time in 3D equals a quantum field in 2D. And that's just the holographic correspondence we mentioned before. Now, when they applied this to certain things, they found out it's called the ER equals EPR holographic correspondence. This was discovered by Susskind and Maldacena a couple of years ago. And what they did is they had two entangled black holes, and they showed that these two entangled black holes, when they modeled them in 3D, and they mapped it over, or in 2D, it corresponds directly to the black hole horizons, which are two-dimensional fields, quantum entangled fields now. When they map it over into 3D, it corresponds exactly to a wormhole metric. So those black holes are no longer really black holes, they're wormholes. So you have entanglement in 2D, and you have I don't know, a Stargate portal or something in 3D. So once they realized this, they got this notion that, well, you know, entanglement defines space-time, which means, well, the wave function defines space-time. And they thought this was kind of peculiar. And so they extended this further, and they found that later on you can actually model whole space-time tensors in terms of entanglement. Not even just wormholes, but just generically. And this was from just this year, from New Scientist magazine. Analysis suggests that the geometry, or that's the space-time, in which a quantum state exists is determined by the entanglement tensor network. And so here we have entanglement being more fundamental than space-time. So now we have this situation, though, where entanglement generates integrated information, thus space-time emerges from a conscious state. Remember I said that integrated information comes from entanglement? Well, I also pointed out before that everything in the universe is entangled, and so therefore you can model the world as one giant conscious state. And then, or you forget about that route entirely, and you go the quantum cognition route, and you say, well, a wave function is a thought, and it's a superposition of wave functions indefinitely, and so you have this situation where you just have wave functions added on wave functions, and you have this universe emerges from another conscious state from thoughts. And this is my digital physics argument. This one actually, a friend of mine was an atheist, converted on this on the first look. Basically, our world is a virtual construct generated from integrated information. Premise 2, conscious states are integrated information. Therefore, our universe is a conscious state, and then conscious states exist inside minds. And so the universe is in the mind of God. And so now we have our digital physics model of the world, where there's, the virtual reality of emergent space-time inside, and it's generated from this world of thoughts on the outside. And, we're actually experiencing, it's kind of, when you talk about beneath space-time, that seems kind of spooky to everyone, right? But remember I pointed out before that, well, your thoughts and emotions, when you try to find your thoughts and emotions in space-time, you can't really find them, right? And so we have this kind of weird situation now where suddenly beneath space-time doesn't seem to be surprising anymore because you already have access to beneath space-time. You can kind of introspect and just see that your thoughts and emotions don't exist anywhere in space. Now, you look at that model, and, well, that looks sneakingly suspicious to the model I just pointed out before. You have, the pleroma, which is the realm of thoughts and Platonic forms and so on, and then inside that is the physical world, and you have the human mind that's connecting between. You go back, it's the same model, the exact same, what we just derived from the philosophy generates, you can get that out of the physics as well, just that's the long way around to do it. And so both science and philosophy point to idealism. And now the third part is Christian Neoplatonism. Interestingly enough, the Bible hints at this as well, and there's enough clues in it to derive the same picture. And first we start out with verses hinting at idealism. This is Acts 17, 27 to 28. He is not far from each one of us, for in him we live and move and exist, and even some of your own poets have said, for we also are his children. And then there's also, he is before all things, and in him all things hold together. That's Colossians 1:17. Now it turns out the poet of Acts 17:28 that Paul is referring to was Aratus of Soli of the 3rd century BC. It's like hymn to Zeus, I think it was. I may be mistaken that, but I think it was that. And then Aratus' poem specifically referenced the creation as being interior to God. And if, well, God is an immaterial mind, that means that the material world is interior to an immaterial mind, which really means that we call the material world is not material at all, but it implies idealism. It's all inside an immaterial mind. Now, the next clue, this was information related to God, is in Genesis, well, how does God create the universe? Just speaks it, right? But, well, it's kind of weird. When I speak words. I don't speak matter. I don't speak and then suddenly, abracadabra, this thing pops out, right? The mouse pops out. Well, in this case, we have God speaking a physical world into existence, and that just seems really weird. And well, you realize, well, it doesn't really seem weird anymore when you realize that the world is information construct. God speaks, and then the lines of programming appear and generates the virtual reality that we're in. And then when you push this further, this is very telling. This was actually quite astonishing. Let's read the verse first, and I'll look at the comparison. By faith we understand the worlds were made by the word of God, so that the things which are seen were not made by things which are visible. So God's word is this invisible thing that creates this visible world. And now we have, this guy is not religious at all, just a scientist who believes in information. He was one of the earlier scientists who believed in information monism. John Archibald Wheeler, who was a colleague of Albert Einstein, said, "It from bit symbolizes the idea that every item of the physical world has at bottom, a very deep bottom in most instances, an immaterial source and explanation." So now we have this very strange parallel where, well, there's, there's the physical world, which corresponds to it. That's the physical item. There's the Word of God, which is, it's a word. There's a bit. A bit of information is like a word you type out on, a computer. And then we have things which are seen and the things which are not seen, and it's the physical world and the immaterial world. It's the exact same thing. It's just digital physics in the Bible, and it's very clear that, the Bible is basically saying the world is not made out of matter. It's made out of the Word of God, or information. So then the question is, what is God's creative word? In the beginning was the Word, and the Word was with God, and the Word was God. He was in the beginning with God. All things were made through him, and without him nothing was made that was made. That's John 1:3, and then of course there's Hebrews 1:2-3. But in these last days he has spoken to us by his Son, whom he appointed heir of all things, and through him also he made the universe. The Son is the radiance of God's glory and the exact representation of his being, sustaining all things by his powerful word. And so we see here God created the universe through the Son, who is the Word of God, or the Logos. And actually that shows up in Neoplatonism. That concept is called the Logos, and it's the first emanation of the One, which is kind of the Neoplatonist concept of God the Father. And actually the word in John 1:1 actually translates to the Logos, which is kind of logic with a capital L, or divinized logic in kind of a Neoplatonist terminology. And so we have God's Word is the Logos, the Son, or Jesus Christ, and that proceeds from the Father, the One, in Neoplatonism. Next, the concept of the pleroma in Neoplatonism. I didn't even realize this, but one of my professors, J.P. Moreland, pointed this out to me. I thought this was the case, and I asked him, he's like, yeah, that was, Paul was using those words specifically to reach the people he was talking to. For it was the Father's good pleasure for all the fullness to dwell in him, and that's Colossians 1:19. The Greek for fullness is pleroma, the exact same word. So the pleroma in Neoplatonism is the immaterial world we just pointed out before, from which the physical world derives. And then if we go, remember I said beforehand that the verses that imply idealism, there's Colossians 1:17, he's before all things, and in him all things hold together. Well, we go back here, and hold on. I think oh yeah, so that's the 1:19, and the context is 1:17, and it's the same thing. It's in him all things hold together. It's the world that contains the physical world, and so Christ is kind of the instantiation of that world. And so we have this situation where the universe is, in Christianity, inside the mind of God. There's the fullness, the Logos, or Christ, which is the spoken word of the Father, and creation, which is this world. And then we compare it to Neoplatonic idealism, or idealistic Neoplatonism, and you have, the pleroma and the hule and the human mind, and then you compare to the physics, and it's the same thing, the virtual reality contained by a mind. And so then there's this atheist friend of mine that he really didn't like me doing this. I started this kind of mini movement on YouTube, and he didn't like that, and so he's saying sarcastically, "So great, you figured it all out. We are a simulation in the mind of our Lord and Savior Jesus Christ." And I'm like, yeah, basically. And he kind of shrieked and ran off. And the cool thing with this is remember how we have automatic knowledge of God from Romans 1, that verse didn't seem to make sense on a material picture of the world? Well, it turns out that's actually built right into our own consciousness. We have, it derives from straight up epistemology. Is we know the material world could be an illusion even though our mind can't, so that's, the world's immaterial. We know dualism is incoherent, and so therefore God has to exist by default. And if idealism is true, that means that what we see as an empirical world can't be fundamental because the empirical world is always a generation of a mind. If you have a dream, well, there's a mind dreaming that dream, right? And so automatically, therefore, we call the empirical has to be secondary in a mental universe. And so therefore, if we see a physical world, that means that automatically there needs to be an immaterial world behind it that's run by God. So conclusions here are God is automatically known by the mere existence of the empirical world, assuming correct epistemology, just Cartesian skepticism and logical coherence. And you're directly aware of this invisible world, actually, because that's where your own thoughts and emotions are. It's not some, spooky. I mean, it is a supernatural world, but it's not spooky, really, because you already have access to it right now, assuming you have, internal thoughts in your own mind. And that corresponds to Romans 1:20, which you mentioned before. For since the creation of the world, God's invisible qualities, its eternal power and divine nature have been clearly seen, being understood from what has been made, so that people are without excuse. And so now what happens when we reject proper epistemology and we just base it on kind of just the empirical world, right? Romans said that people go into foolishness when they do that. So, where was it here? Well, foolishness ensues, and we have, remember how I said that Plantinga pointed out that if the mind's purely material, we can't trust it for rationality? Well, it turns out there are some people that called the limited materialists. This is a big camp in neuroscience right now that say that not only does consciousness not exist, there's one guy, Marvin Minsky, who's a famous AI researcher, who says that his answer to the Chinese room is that understanding really doesn't exist either. It's just a word we use, and there really isn't any such thing as understanding, and people denying qualia. And then we have Krauss, who has the same kind of epistemology, and based on that epistemology we saw in his debate with William Lane Craig, 2 + 2 = 5 for sufficiently large values of 2. Well, I think, let me say that, Solomon pointed out that atheists are fools, so that kind of is a good demonstration of it. Maybe they really are material minds if they think that. 2 + 2 = 5. So the lesson is see to it that no one takes you captive through hollow and deceptive philosophy, which depends on human tradition and the basic principles of this world rather than in Christ. And my mom, way back, always used to think that this was just, get rid of philosophy in general. Well, no, what it actually means is basic principles of this world. So you base your philosophy on kind of naive intuitions about a material world, and of course you're going to get it wrong. You're not going to understand that there's an immaterial world and a God and so on. And also, interestingly, it implies that, this whole thing of we walk by faith, not by sight. Well, we see here in the physical, that's just the surface world. That's not the real world as it is. And so underneath that, that's the world that God's governing it from this other world, and so we don't have to worry about what we see on the surface. God's got it all under control underneath, even though what looks like in the physical world might be bad. And so knowledge of God is therefore built directly into our own consciousness, and that about sums it up.
Okay, we have time for a few questions, and we'll start with Sean.
I have often a long thought about what you said here, and I've always believed that the world and we as individuals are mental projections on the part of God. My question for you is, and what I have difficulty with, is if my mind is independent of physical reality, why does physical reality have such an effect on my mind?
Because it's also mental.
Because why?
What you're calling physical reality isn't physical, it's mental. I turn this upside down.
Well, call it external information then if you want. Why does external information have such an impact on my mind if my mind is independent of that?
Let's say that agents walk in the room right now and start shooting people up from the Matrix, right?
Right.
You're still going to be affected by it, even though you're still affected by the virtual world because you're inside of it, or you're in Counter-Strike, and, you're going to be afraid of the guy running around the corner, even though he maybe just be an NPC or something, and you're also going to get shot by it, and maybe a psychosomatic effect. Well, it's going to be more than a psychosomatic effect, but you're going to have, we call the material world is also mental, and so it's going to have an effect on us.
So I'm not entirely. It's like in The Matrix, which is a very interesting movie, but I'm not really independent of the so-called physical world because I am part of the underlying world as well. I mean, it impacts me.
But yeah, I mean, the whole point is you
can't entirely escape the Matrix.
You can't entirely escape the Matrix. It's still. It's not like it's a completely detached thing. The Matrix is kind of a movie. It's a way to analogize this, but it's not a perfect.
Because in the movie in the Matrix, the idea was that you could escape the Matrix until the third movie, I guess, and when you realize you're really part of it.
Well, I suppose there is heaven, right? I mean, that could be another VR construct.
Right.
You can escape to or something. And I mean, well, have you ever been hurt in a dream?
Yes.
Okay, well, there you go.
Well, I think one thing to keep in mind is that the person who is keeping all of this stuff in order is God. And so the fact that we get injured by what we call reality is evidence that God is bigger than we are.
Gotcha. Yep.
Very thoughtful and interesting presentation, and I think probably not refutable in empirical arguments or philosophical arguments, but I'm wondering about theological. Okay. One of the early idealists in American religious thought was Jonathan Edwards. You probably know
this. Right,
this.
He's an idealist, actually.
So another interesting thing about Edwards, though, is he's a thoroughgoing and committed Calvinist.
Right.
And it does raise the question, if everything exists in the mind of God, that is a much more attractive proposition probably to those coming from a theological perspective of Calvinism or determinism, where God in fact determines everything. Right. How do you deal with issues like determinism if you come from an Arminian perspective, free will, and also the question of, isn't this just a version of panentheism? If we're all in the mind of God and God is all, and in fact everything is God. So I think those are some fundamental theological questions.
I actually got both of these questions before. The first one is free will. Actually, it's interesting because idealism actually implies free will in a sense, and that implies agent causation, where there's the concept that the material brain is driving a material, your mind's processes, and so therefore you're not free. But if mind comes before matter, then it follows that the mind is what's.
So
God has the free will, but then the question
is,
do we have free will?
But what about human free will?
Right. The question then, I think the idea then is that God would grant us bits of our own consciousness to use ourselves. Like he's not. We're gonna have our free will is going to be dependent on God, but God still grants us some control such that we can use our own consciousness too.
And might he grant us that in a matrix or a context of actual material matter?
Yeah.
But it seems to me it's important to creation that there be something other than God, and to reduce everything to maybe
that comes to the second one, and that's an interesting point, because actually when I started this on YouTube, I was kind of a apologetics hack. I kind of came from left field trying to troll atheists with the physics stuff, and I knew that pantheism was a problem, but I didn't know about panentheism. I figured the problem with pantheism was just that it identifies the universe with God, and so therefore if God includes outside the universe, it's not a problem anymore. And I actually made a video where I hadn't distinguished between what's called strong and weak panentheism at the time, and I had raised some objections. I realized I have to kind of go back and clear. I mean, the video was actually pretty good in the whole. I drive the Christian story, but the problem was that some of the parts of the video looked like it could have a strong panentheism in it. And well, the catch with this is it's just a matter of there's two kinds of panentheism. There's strong panentheism, which is it's all God in the strict sense, and then there's weak panentheism, which is there's God's mind, and then there are the thoughts inside God's mind, but God is not God's thoughts. And a good example of this would be, Huck Finn is not Mark Twain. Huck Finn is in the mind of Mark Twain. He's a mental creation of Mark Twain, but they're two different people. And so therefore there's God's mind, God's I, and that's separate from the little minds.
They're both forms of panentheism.
Both forms of panentheism, but the second one is not really a problem.
Most Orthodox Christians would have problems with it. Nancy Murphy at Fuller is a non-reducible materialist, and I have trouble with her because I think that there is a spirit side of it, but I think this is the other extreme.
And she mentioned, it was funny because Moreland we talked about Nancy Murphy in class and how she was a super materialist. She's like, doesn't believe in demons or angels. He said, she's a Christian. Does she believe in demon possession? I'm like, and then so actually, Moreland said actually she was asked that in class, and there's this situation where, there's she actually said in the conference, actually I don't have demons or angels in my model, and then they're like, well, some of them then said, well, what about God? God is an immaterial mind. And she's like, well, I'm working. That's the problem for my model, but I'm working on it. So I think the answer with this is that, you might want to call it weak panentheism if you want, but the thing is this problem, because the Eastern Orthodox Church is weak panentheist, and they've actually run across this problem before, and so they've solved it by calling what they call the energies essence distinction, where there's God's essence, which is God himself, and then the energies that kind of proceed from God, and that's what creation is. And so God's energies are therefore distinct from God's essence, and that's kind of how they solve it. And that's
He can allow portions of himself to act independently of his own will.
Well, he's running a simulation, I guess, and he's letting things.
He's letting things act separately from himself.
If he wants to. If he it's still, he can still call the shots and just put an end to it right then if he wants, but he gives us free.
That's why this is attractive to. This tends to be attractive to Reformed thinkers and Reformed epistemology. The
Right.
epistemology you're describing here is essentially Reformed epistemology, and most Arminian theologians or philosophers. That's why we would have difficulty with this.
Right. I'm actually, believe it or not, an Arminian myself, so I've read it. This has come up before. I know. Well, the other funny thing is with this is that there is actually an argument from free will towards idealism, and it comes from, this is the Conway-Coken free will theorem, and what they showed was, remember I said that of course the question is it God's mind or is it our mind, but then I pointed out in the von Neumann chains that our minds do collapsing too, and so what they said is either matter causes mind or mind causes matter. And so now we have this situation of, well, we've demonstrated non-realism in quantum mechanics where the particle doesn't actually exist before you look at it. And so therefore, if it's our mind that's doing the processing, or the observing, then therefore our mind is causing the matter, and therefore there's at least agent causation there. And so, we choose what we were going to do the experiment, and we're going to have free will. And of course, God can do all that too. He can choose to make, the world this way or that way, but then there is a little tiny percentage of that God grants to us to choose to do, experiments. And so they actually showed that if free will does not exist, then that means that in some of these experiments, the laws of physics would have to have conspired eons in advance to generate everything up to the exact point of measurement. And so
You also said something about creating a robot that looks like it has free will but doesn't really. How do we know that we aren't like that?
Well, it didn't say that has free will. It behaves, because you can create robots like on, there's some of those.
Right, but acts indistinguishably from what you would expect from another person.
Well, that's an interesting question. Penrose had this book where he talked about that, and he thought that that wasn't completely true. That was Searle's argument, and I think Searle was saying that. There's a lot of our things which are kind of predictable in some respects, right? So, for example, our understanding. If I ask you the question 2 + 2 = 4, or what is 2 + 2? Unless you're Lawrence Krauss, you're going to say the answer is 4, right?
Right.
And, well, Lawrence Krauss is crazy because he's an atheist and he refuses any immaterial things, and so therefore he insists that it's all empirical, and so therefore 2 + 2 = 5, but we can kind of predict that from him too. So
It's always been my thought, though, that from the human perspective, you can't really tell. I can't really prove my own freedom.
that's
I have
an interesting point.
have to sort of depend on faith that God has given it to me because He said so.
Yeah, I can make arguments for free will, but I think at the end I might have to agree with you. There are arguments against, and I agree with you that we have free will, but
But it's hard to prove.
it's hard to prove.
Yeah.
I have some arguments, but I'm on your side on that, and I've dealt with this. I've had this problem come up with my model before, and I have some solutions to it, but it's kind of in the works. So.
Okay. Did you still want to speak?
Well, I was wondering how you would distinguish between pantheism and this line of thinking.
Well, that was beforehand, so how do I get it back up? Uh-oh. Oh, it's off. Okay. So, well, that was kind of the energies essence distinction issue from before, where you have, there's pantheism is the universe is God. There's panentheism, the universe is inside of God. But then there's the question, is panentheism orthodox too? And so then there's the situation of strong versus weak panentheism. And so then there's strong panentheism, which says that all is God, which is, that's got problems with it. But then there's weak panentheism, which says that there's God, but then there's God's thoughts, and God's thoughts are not God in the same way that Huck Finn is not Mark Twain. So there's God's creations are not God just because they happen to be programs inside God. Now, an interesting thought on this, if you don't take this model anyway, is just look at omniscience for a second. God knows everything in existence, right? That means he knows the number, your hairs in your head counted and all this. And if he has that down to the exact atomic level, subatomic level, he has knowledge of all those quantum states too, and so therefore he has an exact simulation of the universe going on inside of his mind right now, simply because he's omniscient. And well, if it's an exact simulation, it has the exact, even the qualitative states and so on, those people that are in his mind would not be able to tell if they're in the real world or just the world where there's, that's generated by God's omniscience. And so we can't really tell which of those we're in anyway, even if you say there's a physical world here and there's God's mind over here, just because there's God's omniscience is there, means that, yeah, exactly. So it's kind of an interesting problem. But this is a problem that has come up, and my current solution to this is the energies essence distinction that they've come up with in the Orthodox Church. So.
Two-part question. The first one's easy, second one's a little bit more complicated. Now, everything you've been basing this proposal in is based upon the ideas of quantum mechanics.
Right.
Now, from the quantum mechanic point of view, which we have a very difficult time analyzing because of all the probabilities and this thing, that we just don't have the ability to measure various things, the uncertainty principle, things like that. Here's the question from a different point of view. Does God not have the ability to measure both the velocity and the position of a particle?
That's an interesting question. This actually, an atheist brought this up as an argument against God, and my solution was, I said that, well, there's the Heisenberg uncertainty principle. I said God can't measure both, but I said, well, if you get rid of materialism, well, there's not a problem there because the position doesn't actually exist before you measure it. And they actually have this experiment called the quantum Cheshire cat now, and this is very infuriating to materialists, where they have the particle and they split one of the properties off from the particle. Remember in Alice in Wonderland where there's this big smiley face grin floating off over here and there's the cat here? Well, they actually have that now with quantum particles. They can take a property and just take it off the particle and it's floating off in free space. And there's the particle going. And they can do this with any properties. And in theory, you could take the one particle and just split all of its properties off everywhere, and then you have a particle with no properties. Well, that's a problem now because, well, what's the if I take this mouse and take away the white on it, it's transparent. Take away the feeling of it, I can't feel it. Take away the property of volume and spatial extent. Can you really say the mouse exists? You have all the properties just floating off, and well, you've just disintegrated the particle into pure information, and so.
So you're basically removing even the quantum mechanics type of thing because you're going below that to say nothing is real.
Exactly. It's not that God measures the position and doesn't know the velocity. It's not that God doesn't know the velocity. It's that the velocity isn't there because God isn't simulating it.
Okay. So then that leads to my important question, and that is this. You have now removed realism. You've now removed determinism of Einstein. You've removed the quantum mechanics of the last century. And so you're basing it totally on a projection of God's mind that everything exists in this way. How can any of that be in any way demonstrated from your argument or from the next guy's argument who disagrees entirely with everything you've just said from a philosophical point of view? How do we not know we are not Mark Twain's mysterious stranger, which at the very end of the story is a floating speck of matter through space, and everything he's ever thought in his entire life is actually just his own consciousness projected around himself? How do we not know we're that rather than living in the mind of God or anything other philosophy?
How do we distinguish this from solipsism?
Yes. How do we know anything in the universe is real or from the mind of God in any way?
Right. Well, you have rationality, but you've got this. You put yourself into a solipsistic box. This is actually kind of interesting. And there's I can't remember the name of this guy. Richard Kahn Henry from Johns Hopkins University pointed this out, and he said, "Well, from quantum mechanics, we have this choice now. We can either say it's solipsism, and it's all that that's all that exists, or we have." theism out of this, and he said, yeah, he was pointing out that this is why physicists were so recalcitrant. Remember I mentioned that poll before where they had 50-some% of the physicists didn't believe their own math? Like actually they said, we know this is what the theory says, we know this is predicted every experiment to date, but it's not true because it can't be true because it's ridiculous if it was true. And actually I had a physicist actually tell me that, like to my face once. He said that no one actually believes in quantum mechanics.
I think that if I was solipsistic and I am creating everything around me, that I would be better at it.
That's a good argument against it. We'd all have superpowers. We'd all have superpowers to be able to.
Fly around.
Yeah.
But my question
wait a minute.
But my question is, how does anything of what we're saying can be demonstrated? How can anybody demonstrate anything?
Well, even if you're solipsistic, this physics works because if you're solipsistic, it's all a generation of information in your mind, right? Remember the first example I had where there was the physics student who discovers that his own universe has a speed limit.
Yes.
Well, that's a solipsist world. That's not because he's in a dream. He doesn't realize he's in that dream for 10 years, and he's stuck there and he's doing physics there, and that actually is a solipsist world. And so, on the physics half, you probably can't really distinguish between solipsism and theism. But I think solipsism.
Wake up within your own dream.
Right.
Which I've done before. That's kind of fun. When you wake up in your own dream, then you can control it.
Yeah,
I've never been able to wake up in this one.
That's a good way. That's a good practical argument against it. And there is the argument, of course, that solipsism it just seems kind of ridiculous, and so we'll just take it a matter of faith that God exists and that solipsism is false. But that isn't much of a leap because everyone, even the atheists, make that leap of faith every single day. So. And then there are some possibilities for defeaters of solipsism that I've been playing with some friends, but they require idealism to work, but it's a little more complicated. So.
Well, thank you very much for coming, and those of you who have further questions are welcome to talk with him until he can't stay any longer.
Okay.
And Johannan Ratz, thank you very much for coming as well.